Hi, hello everybody. So this is section 24, the quadratic formula. And for this section, we're dividing the video into two parts. This is the first part where we go over the quadratic formula, and the second part, we'll go over the applications associated with this formula. Now, in the past, we have looked at this equation, the quadratic equation, ax squared plus bx plus c equals to 0, and we solved it by factoring. Okay? Now, just keep in mind that A, B, and C are the coefficients, and in many cases, it was possible before to solve it by factoring, but now we may uh, encounter some equations that are not factorable, such as this one. Now, remember, we just review a little bit how to do this. The technique was called the AC method to factor trinomials with leading coefficient 1. In this case, A is 1, B is 1, C is -5. And the technique was find a pair of integers whose product is A times C, which in this case is 1 times -5, and whose sum is the B coefficient, which in this case is 1. And we looked at this number and we tried to find two numbers whose product is -5. So either this or that. The problem is, in this case, even though the product is -5 for both cases, right? 1 times -5, -1 times 5. The problem is the sum here is -4, and the sum here is 4. It doesn't add up to 1. Now, what does that mean? It means that this equation here is not factorable. Not factorable or prime. In that case, we have to use a different technique. So there are two techniques available. One is what we saw before called completing the square and the square root property. And the other is the derivation of the complete the square technique, which is called the quadratic formula that you see over here. Now, just keep in mind that a cannot be 0 because if it is, this would be a linear equation. So once we solve the general quadratic formula, ax squared plus bx plus c, we get this formula right here, minus b plus or minus square root of b squared minus 4ac over 2a. It's important to notice that there's going to be two solutions coming from here, and we'll see it when we solve it, one involving the plus, the other involving the minus. So the plus and minus come from the square root property after we complete the square. Okay, so keep in mind, up to two solutions to the equation, one with the positive, one with the negative. So let's take a look at the first equation that we can solve, and let's solve this very same one, x squared plus x minus 5, using the quadratic formula. I'm going to leave it here for us to see and see what the answer is. And we'll see that the result, the values would not be possible to factor. Now, as we solve these equations using the quadratic formula, it's important to understand that the equation has to be in this format with equal to 0. If it is not in this format, then we must put it in this format, right? Ax squared plus bx plus c equals 0. Now, we first identify A, B, and C. That might be useful, right? A in this case is 1. Again, B is 1. C is -5. So now all we have to do is write the quadratic formula as we see over here. So minus B minus 1 plus or minus B squared minus 4 times A times C, -5. Everything over 2 times A. All right. Now, when we get to this point, it's important that you do not simplify anything. And the very next thing that you're going to do is evaluate the radical or the radicand. So -1, 2 here, plus or minus stays. And we do this aside somewhere. So let's see, 1 square minus 4 times 1 times -5. So 1 square is 1, so this is PEMDAS, right? I have -4 times -5, which is positive 20. So this is 21. So I'm going to write 21 here. So now the equation simplifies to -1 plus or minus radical 21 over 2. And when you got the answer to this point, you would take a look at the radical to see if you can simplify the radical. But 21 is just 3 times 7, and there's nothing that you can do there. So then you write both solutions separately. -1. Let's write this thing correctly. -1 plus radical 21 over 2, and the other being -1 minus radical 21 over 2. And this is as far as we can go. And these are the two solutions. And obviously, you can see that these values would not be possible to be factorable, right? We would never come up with -1 plus radical 21 over 2. So this is how you use the quadratic formula in solving these non-factorable uh, uh, quadratic equations. Now, just keep in mind, the quadratic formula can also be used on equations that are factorable. And you can try it. You can try it later and test it out. Now, let's take a look at the other example I have here for us to see. 24.5. We have to solve this quadratic formula, but notice the quadratic formula is not in standard form. This -10 cannot be here, so I have to add 10 to both sides in order to put it in standard form. So I have x squared plus 7x plus 10, and these two cancel, I get 0. All right, now I identify A, B, and C. Let's do that. So A again is 1, B is 7, and C is 10. We now are going to write the quadratic formula, which is, I'm going to write it over here in case you forgot, minus b plus or minus b squared minus 4ac. Notice everything over 2a, not just the radical, everything over 2a. So minus b minus 7 plus or minus square root b squared, 7 squared, minus 4 times a times c, everything over 2 times a, which is 2 times 1. -7 plus or minus. And now, aside, I have to evaluate this radical. So I'm going to do it here on the side or on my scrap paper. 49 minus 4 times 10 minus 40, which is 9. So I'm going to write 9 here over 2. Now, in this case, notice I can simplify square root of 9 or radical 9. -7 plus or minus, obviously, 3 over 2. Okay? And now we are going to get two answers. The first one is going to involve a positive 3 over 2. And the second one would be -3 over 2. All I have to do now is evaluate the numerator. So -7 plus 3, -4 over 2, or -2. And -7, -3, -10 over 2, or -5. Okay? Now, if you get two integers, what does it mean? Well, first of all, those are the solutions to the equation, but in addition, that means that the original equation was factorable. We can take a look and try to solve by factoring, right? AC method again, A times C, which is 10. and the sum, which is b, which is 7. So it's either 1 and 10 or 2 and 5. And you can see it's 2 and 5 because the product is 10 and the sum is 7. So this will factor to x plus 2, x plus 5. And now by the zero product rule, this gives you -2, and this gives you the -5. Now, in this case, this is factorable, but we solved it by the quadratic formula. Okay, so the quadratic formula works whether the equation is factorable or not. All right, let's do the last one. And I'm going to erase this a little bit. Can always stop the video if you want to. I'm going to write the quadratic formula again. I'm sorry I deleted that. B squared minus 4AC. It kind of helps the more you write it, it makes it easier to remember. Now, again, I have to solve this quadratic formula, but it's not in standard form, so the 6x minus 3 has to move to the other side. So I'm going to subtract 6x from both sides, and I'm going to add 3 to both sides. Okay, and now I am going to have 4x squared minus 6x plus 3 equals obviously 0. These two cancel. Now, always write the quadratic formula in decreasing order of exponents, which is x squared, x, no x. Okay? Identify now a, b, and c. A is 4, b is -6, c is 3, and we put those values into quadratic formula up here. Now, this is a very good problem for the following reason. Notice that b is negative, but the formula says -b. So it's minus a -6 or -6. Be very careful, plus or minus. B squared, -6 squared minus 4 times a, 4 times c, 3, everything over 2 times a. Okay? So this is +6, plus or minus. Obviously, the denominator is 8. And in my radical, I have to evaluate. Notice I don't simplify anything yet. I have to evaluate the radical separately. So here I'm going to come to the side and I'm going to do this. -6 squared minus 4 times 4 times 3. And let's see what we have. So this is -6 squared is 36 minus this 4 times 3 is 12 times the -4 is -48. All right, when we can check, this is 12 times 4, 48 with a negative. Now I have 36 minus 48, which is -12. So -12 goes inside of the radical. All right, and you maybe find a little strange because it's negative. We cannot evaluate -12. Yes, we cannot. It's not a real number. Okay, it's not a real number. So what do? We have to simplify this radical using imaginary numbers. So the -12 is going to become 12i squared, right? Imaginary numbers. Now we break that into this. And 12, it's not a perfect square. So I have to break this a little further. So this is going to be radical 4, radical 3, radical I squared. This is 2. The radical 3 stays as radical 3, and this is I. And the way we write this is always leave the radical last. 2i radical 3. So the radical -12 is going to be replaced with 2i radical 3. So now look what we do. 6 plus or minus 2i radical 3 over 8 over 8. Do it separately because otherwise you may make a mistake. Simplify the first by 2 3/4. Simplify that by 2 plus I radical 3 over 4. And the second one, 3/4 minus I radical 3 over 4. Okay, so you saw in this example, which is a very good example, that it is possible not only to use the quadratic formula to solve an equation that's not factorable, this equation was not factorable, and that the answer required an imaginary number, as you can see over here. Okay, so this is the first part of section 24, where we learn how to use the quadratic formula. In the next video, we'll apply this to solving application problems.